Hello, I'm Johnny Devine, a science teacher in Tacoma, Washington. In this video, I'll share tips and insights about the second student product of the Sticks and Stones project, the Sling. In my previous video, I explained how the Knowledge and Action curriculum uses the Sling as a project-based means to investigate concepts of uniform circular motion and reinforce two-dimensional kinematics. In this video, I'll share some easy construction techniques and pitfalls that I've discovered. Be sure to maintain a safe environment. I collect and keep my students' slings during and after the project, and we always wear safety glasses when constructing and testing. To construct the sling, students will need scrap fabric, sharp cutting tools, safety pins, some string or cord, and tennis balls for the projectiles. I buy my fabric from a local thrift store, which usually has bagfuls for just a couple dollars. I've found that upholstery fabric is a nice balance of strength and workability, but just about any fabric will do. When it comes to the cord, having something a little thicker seems easier to handle and less prone to tangling, but usually costs more money. As with the bowstrings, I find that braided nylon is a good compromise, though strength is much less of a consideration here, so even a simple twisted masonry line will work. The largest parameter that students vary between their slings is the length of the string. This is the radius of the circle their projectile travels in before being launched, so they develop a hands-on understanding of the relationship between radius, circumference, period, rotational kinematics, and tangential velocity. An arm's length is a practical starting point for a sling. Then I usually have students experiment with lengths 20 to 30 centimeters above and below this length. Students begin construction by cutting out the fabric that will become the pouch of their sling. A 12-inch by 6-inch rectangle is a good starting point. To attach the string and make the fabric more pouch-like, I have students fold over the corners of one of the long ends. By folding all these flaps over and cutting partway through them with scissors, they create a hole through everything that can then receive a string. Overall, the forces generated on the sling are not much compared to the bow, so I give the students more freedom in their knot choice. Here, I use a square knot. The entire operation is simply repeated for the opposite side. With both strings now attached, one string should have a loop put in the end and the other a bulky knot. The loop is slipped over a finger so the entire sling doesn't go flying away when the projectile is released. The knot is held between thumb and forefinger as the sling is brought up to speed. When ready to release the projectile, one simply releases the knot. The loop can be made by taking a fold of string near the end and putting an overhand knot in it. If the loop is too loose, students can use it to create a girth hitch around their finger. The gripping knot can be made larger by tying overhand knots repeatedly in the same location. One of the biggest challenges of these type of slings is there's not much of a pocket for the projectile to sit in. They tend to roll out of the fabric before they can be brought up to speed. I provide safety pins for my students so they can adjust the depth of their pockets. If they make too deep of a pocket, they may have a hard time getting the projectile to release, so they should experiment. Regarding technique for using the slings, I have my students stick with a circular path that is perpendicular to the ground versus a flat circle above the head. It is easier to get the ball moving and results in fewer balls going the wrong direction at our testing range. In the next video, I will discuss the final student product of the Sticks and Stones project, the atlatl.